All right, well, why don't we go ahead and get started. I'd like to thank everybody for joining us today. And this CNCF webinar is Introducing Kubernetes IoT Edge Working Group. My name is Randy Abernathy. I'm a CNCF ambassador and a managing partner at RxM. And I'm going to moderate the webinar today. And I'd like to welcome our presenter, Dejan Bosanek, software engineer at Red Hat. And before we jump in, though, I just want to hit a few housekeeping items. The attendees can't enable audio during the conference, but there is a QA box. So if you look down at the bottom of the Zoom screen, you'll see Q&A. And in the Q&A, you can drop in questions. And then at the end, I'll kind of go through the questions and we'll see if we can get Dan to give us some answers as much as time as we have for running through the questions at the end. So drop any questions that you've got in there as we go through the material. The session is being recorded also, and so that's going to be sent out, as you can see in the chat there. There's a link in the chat, and it'll also go out by email. So if you were signed up for the seminar, you'll get that as well. Okay, well, with that out of the way, I'll hand it over to Dejan.
Thank you. So, hi. First, a brief introduction to me. As Randy said, I'm a senior engineer at Red Hat, working on the IoT and messaging team, and I've been around for the last, I don't know how it is, like 9 months since we started the IoT Edge working group within the Kubernetes community, and I would like to present a little bit more about it today. So the reason we started this working group is that in the last couple of years we see that more and more people are trying to deploy IoT and Edge solutions using Kubernetes, and there was a lot of questions being asked on how we can use Kubernetes as a platform for all these kind of use cases, from trying to deploy IoT cloud platforms in the Kubernetes to deploying certain nodes in the edge or the whole clusters on the edge. So the idea was to form a working group as a community where we can discuss all these topics around IoT and edge computing. And first, to start with what edge means and kind of establish like a common vocabulary, because people coming from different industries, from different areas, when people say edge, they mean different things. So we started first with the idea to bring all this concept together and try to distill what's relevant in the Kubernetes concepts. So we tried to collect the use cases, the workloads and applications that are common to the Kubernetes on the edge. Try to answer the most important question, and that's why would you use Kubernetes in such an environment? Is it a good fit as a technology at all, or is there a better technology solutions that could be used? And then finally, when we start looking at how we're going to use Kubernetes to run those workloads in the IoT and Edge context, what are the key challenges people are facing to do that? Because once you're moved out your centralized data center, there are different aspects that will affect how Kubernetes work in these environments. So that's what I want to discuss a little bit today, just to share some things where we are with these discussions and what are our plans for the future, and hopefully I can get you interested into topics and to join us in this working group to shape this this area more in the future. So we'll start with a brief introduction to the edge computing in Kubernetes. We won't go too deep into this because there's a lot of other places where people are defining the edge computing in general. So, but we need to do this in order to, as I said, define the common vocabulary and to understand what we mean when we mention certain terms. Then we'll go through typical workloads that we identified that are useful when people trying to run things on the edge with Kubernetes. Discuss what are the challenges when you try to use Kubernetes in this context. And then finally, shout out to a couple of projects that are starting to appear to address some of these issues in the landscape. And finally, talk a little bit about where what this particular group will focus in the coming months. So what's edge computing? That's the first question, and one like jokingly answer is like edge is everything that's not located in the cloud, right? But to be more precise, we can define edge as an effort to deploy workloads, services, and applications closest to the users and the devices that are basically originators of the data for those services and ultimate consumers of the data produced by those services. Why would you want to do that? That's another valid question. So why would you even consider deploying something outside of the centralized cloud? So there's a couple of aspects that usually pops up when the conversations start on this topic. One of the most prominent is tackling the latency. So all the latency sensitive workloads are better deployed as close as possible to the users and devices that needs those services. Other is availability. So deploying the workloads on the edge side and on the sites that doesn't have bulletproof connectivity to the central cloud, but making them work properly, even if they're offline, and serving the users and devices in those sites is one of the crucial use case. Data locality. More and more we see the policies that make moving and sharing large amounts of data popping up. So in some cases you might want your data to never leave your factory, your enterprise location, your remote site. So you want to have a processing of the data locally, but you still want to use cloud native development style. So in that case, you might want to consider deploying pods and workloads on the edge sites, and the list goes on. But these are basically the three main incentives for people to even start considering doing edge computing. Use cases, coming from two previous slides, we can see where this can fit into various industries and existing industries like IoT, for example. There were always kind of a way in IoT to create gateways that will do some data pre-processing and things like that. So we see the trend that more and more people want to containerize those gateways and manage them using the cloud resources. So that's the natural fit. So all the providers also want to use their infrastructure to provide new services. So telcos, ISPs, CDN providers already have a lot of edge infrastructure, so to say. So why not use that to serve some of the applications better to the local users? And in the terms of latency, video game servers are probably the best example to explain the latency requirements for edge applications, and the compute offload doing intensive computing for the VR or AI can be offloaded to the edge sites as well. So the next typical question is like everybody's saying edge, thinking about different things. So I think it's important to distinguish what edge means to different people, and here usually you can divide things in the two separate categories. First one is the infrastructure edge. I also read somewhere today the term heavy edge, which also could describe this category pretty well. And you can see this is the edge, so edge site which is outside of the public centralized cloud, but it still have a good networking infrastructure and basically more resources there. So when we talk about this in the Kubernetes context, we can see that people talk about deploying the whole Kubernetes clusters on the edge sites, talking about hybrid clouds or federated clusters, kind of use cases there. But then we can go even one step further and deploy our compute resources even closer to the users and devices. And here we usually talk about like enterprise retail stores, offices, factories, and things like that. And here we have a different, again, different networking requirements and different compute resources that are available. And here we can talk about two things. So we can also talk about deploying the Kubernetes clusters in these areas, but also there are use cases where you want to have like a pure IoT solution where your edge nodes are basically just that, Kubernetes nodes, not the whole cluster, but having the cluster nodes managed by the same control plane as the rest of the cluster infrastructure. Again, another why. I think it's important to ask a lot of whys when you talk about things like this, and this is like, why would you want to use Kubernetes for all this? So we see that you know, cloud native computing is where the developers are today, and all the tooling and all the best practices are being developed for that. So it makes sense to try to reuse all that effort and just to develop and deploy a little bit different kind of workloads for the edge, right? So why, you know, invent something completely orthogonal to something we already have today? And the other thing is that Kubernetes architecture is pretty good for this kind of use cases, even no matter what kind of scenario you're talking about, deploying the whole clusters or the edge, or deploying only certain nodes on the edge. A lot of tooling, a lot of works had been already done on this front, so it makes sense to try to reuse all that to tackle all these new deployment problems. Now we can talk a little bit in general about what are the challenges are when you start moving your workloads from the centralized cloud to to the edge. And as far as I can see, you can broadly categorize these challenges into three main groups. So the first group is like an infrastructure plane. And this is always the case when you talk about any kind of IoT and edge computing. And that's like, how do you put your compute resources on the edge, and how do you install them? So it's those edge sites are not usually not a typical data center. So there's a lot of considerations to be taken care of how you put your resources there, how you secure them, and how do you create a proper cluster or proper infrastructure on the edge site. The other one is the control plane. So now that we have our resources and reaching out to the edge, how do we schedule our workloads there, and how do we manage them? Because one of the recurring patterns going on is that the networking between the edge and the cloud is different. So all the things that we taking for granted in the cloud are a little bit different now. So we need to think a little bit more about that. And finally, there's a data plane challenge, and this is how these edge workloads communicate with the cloud, and even how do we enable edge sites to communicate with each other. So far we had a little bit, so I'll talk now a little bit around where we are at the moment around discussing all these things, and how do we define them, and hopefully that will help putting things more in the perspective. So first we'll start by talking about what kind of workloads are suitable and to be run in this context. But before we start with that, one of the things that needs to be mentioned is that there are a lot of features in Kubernetes that are usually not used that much in the pure cloud environment because simply they are not that important in those kind of use cases. So when you start talking about the edge computing and using Kubernetes in that space, some of those features become more important, and we'll talk about a little bit more about those later on. But one of the first things that we can see is like how can we use how can we influence Kubernetes scheduler to better schedule workloads to the edge nodes. For example, if we have a constraint node that only a certain workloads needs to run, then we can use taints and tolerations to basically instruct the scheduler to put only appropriate workloads to the edge node. So as you can see, we can taint the node with the kubectl command, saying that only the pods that have edge equals true in these basic examples toleration on themselves should be considered to be scheduled on this particular node. So when we have a node defined like this, we can basically see above the two pod specifications, and on the left side the specification have a toleration for this. So meaning that this pod is able to run on the edge node, while any other node without that toleration, for example, the node the pod on the right will never be considered to be scheduled on the edge node. So this is just one of the examples of and we'll talk about taints and tolerations a little bit more in this workload session. So I thought it would be useful to just share it here up front to give it a bit more context on how that can be used to schedule workloads on the edge nodes. So if we again take a look at the different kind of workloads and try to answer the same old why question. So what why are we deploying workloads on the edge? And again, there's three broad categories so far identified. So workloads that will help us with data ingestion and preprocessing, the workloads that will help us with the reliability and availability of the edge sites, and finally the workloads that will help us have a better latency for the applications and workloads that need it. So let's dig a little bit deeper into this. So what we mean by the workloads that help with the data ingestion. So in many IoT use cases, we have a bunch of devices that are talking what we call like a field protocols, and there's a lot of these protocols, a lot of them even non-IP based. So and this is the traditional job of the IoT gateway is to do like a IP onboarding of all these kind of devices, getting the data from them and putting them into something that's more convenient to be consumed by the cloud, basically, right? So a typical example in the industrial IoT would be like the Modbus, or in the consumer IoT, the Bluetooth. So the nodes that would do this kind of job would get the data from the devices and convert those into some more common protocol like MQTT or HTTP or AMQP, right? And send those data to be processed further down the stack. So as I said, one of the couple of things that Kubernetes provides as features less known to do this is device plugins. So device plugins allows device manufacturers to basically write plugins to advertise their hardware to the kubelet, and then the pods and containers workloads can request those those features. And we can also use the taints and tolerations to basically make sure that workloads are scheduled to the appropriate nodes that have appropriate features, right? So once we have this data in appropriate format that we can use for processing, we can do some more pre-processing of the data on the edge as well. And there's two things why would you want to do that. So, or even more. So we can do a basic normalizations of the data structure read by devices to make it easier to identify the context of the data later on in the applications. And we can add a lot of metadata about location, identity, of origin of the data, add necessary security context to the data. But also for more advanced use cases, when you, as we said earlier, sometimes the bandwidth between the edge sites and the cloud is constrained or very expensive. We can use some data analytics on the edge site as well. So doing some data preprocessing, data analytics, and sending only the relevant data up for processing. So basically trying to separate noise from the actual useful data there. As the slide says, so there's nothing specific about these workloads. Again, they need to be properly containerized and scheduled to appropriate edge containers, edge nodes or clusters, depending on the particular deployment. Reliability and high availability. So just to remind that we said that as one of the main use cases for edge computing. So being able to operate in the offline mode for prolonged periods of time, and considering that a normal thing. So for that, you usually want to be able to store some of the data on the edge sites, and usually we storing data temporarily on the site is a two-way thing. So you can basically do buffer and batch or store and forward, meaning that your devices and applications will continue producing data and sending like everything is working fine, even if the connection is down. So this means that we need to deploy some kind of the message brokering on the edge sites, so that the broker buffers all the traffic and then sends it upload when the link is up, right? Other is providing the data for the services running locally. So doing some kind of caching of the state of the applications running in the applications locally on the nodes, so that workloads and services can continue working normally, even if the site is offline. So one of the biggest considerations here is we'll talk a little bit about it in a few slides, but having limited capacity is usually what we have on the edge. So making sure that all these workloads have enough storage, for example, to hold enough data for the planned offline activity, right? That's the main concern for this particular use case. Serverless is all the rage these days, and it makes sense for Latency to try to see how we can deploy functions locally on the edge sites, so they can react on the sensor or user events, or even on the schedule events. So that's one of the big areas that can be explored in this context. And also for the latency, we see that there are a lot of interest in running machine learning on the edge. So you can see those of two different approaches to that. Basically deploying the cloud trained models which will be executed on the edge, and the other one is edge specific training, which is conditioned on the environment and the data policy for the particular site. Again, here we can still use device plugins and taints and tolerances to make sure that appropriate workloads are scheduled to the nodes with the appropriate capabilities. So now that we went through like a basic questions of why would you want to do that, there's always a question of what are the challenges, because each time you step out of your centralized cloud, you get a pretty different system, right? So two main things are usually discussed in this context, and that's the limited compute resources on the edge side, and the problem with the network. So network can be unsecure, unreliable, and limited in bandwidth. So in the next couple of slides, I'll go through again a couple of Kubernetes features that are less mentioned in the pure cloud space, but could be a helpful tool to mitigate these challenges on the edge. So when you're running in the cloud, auto scaling is something that is usually taken for granted. So if you need more resources, it's usually fairly easy to add more nodes and scale out your solution. But as we said, deploying things on the edge is more complicated. So basically you're ending up with having the limited number of nodes there. So that's where we can use a prioritization toolkit, which could help us to make sure that important workloads are always scheduled properly on the edge nodes. And there's a two aspect to this. So we can define priority classes for our workloads, and basically define them as assign them to a different pods. And when the pod has a priority, and when it goes to the scheduler to be scheduled on a certain node, if there is no if it can be scheduled, some of the less priority workloads will be evicted, will be preempted or evicted from that node, in order to allow us to schedule more priority workloads. The other feature is called quality of service, and this is not the explicit but rather implicit configuration for the workloads. So each container in the pod can have like a very set CPU and memory limits, and if both of those limits are set on all the containers, we can say that the quality of service for this particular pod is set to be guaranteed. If only some of the containers have the limit, then the pods are considered burstable, And in default case, if we don't have any limits, any requirements set for the containers, then the workload is considered to be the best effort. So with these two properties of the pods, we can basically configure our system to have like a properly important and high priority pods being considered as a first class citizens by the scheduler, and then some less priority workloads like some things that should be running in the off hours and maintenance tasks and things like that can be considered with the less priority. The other thing that's always important is the networking between the edge sites and the nodes. This isn't so much a concern for a full, let's say, infrastructure edge where things are running in the service providers, but even for the enterprise edge where you want your workloads to run in a retail store. Those things usually have asymmetric network capabilities, and all the workloads running there are basically competing for the same resource, right? So here again, we want to have some kind of tools to like limit the bandwidth to certain workloads and give the priority for the bandwidth for the more priority workloads. So first tool we have here is a network policy, which basically define a little bit and help us a little bit with the security of the edge workloads, because it can be used to apply a certain like a firewall rules to pods selected by the pod selector. So we can define the rules and the set of IP addresses that can be used for ingress and egress for the certain pods, which is an important issue when you're running in the untrusted edge environment. The traffic shaping, the other topic for the network is always the bandwidth. As we said, a lot of workloads are competing for the same networking resources, and even if the bandwidth can be restricted on the number of layers in the system, what we are usually most interested in is how do we constrain a certain node and the pods within that node with a certain bandwidth, and that's where the CNI plugin help us, because it can it can be set with the bandwidth capability set to true. Basically, CNI allows us to define the networking interfaces that the Kubernetes node will use, and with it we can, as you can see in this example, we can set basically ingress rates and egress rates for the node itself over the certain interface, which can be useful in a scenario where you can maybe have a backup interface going over slow and expensive, like a cellular network or satellite network. So it makes sense to try to make sure that the bandwidth is kept when using that interface. But when the bandwidth capability is turned on, we can then annotate our pods even in the running in a certain node, and basically limit the number of the bandwidth those pods will be using when running on a certain node. So this was just a little bit of examples of what are the challenges and what people are thinking about, where they're thinking about scheduling things and deploying them in the edge environments. But as we said, there's a lot of things going on in the community, and there's an interest in the edge computing, and a lot of projects are popping up. So basically, the whole Kubernetes platform is struggling with three main things, and it's as I said, infrastructure challenges, how to deploy edge clusters on the edge, how to deal with the unreliable network between the control plane and the nodes, and how do we deal with those constrained resources. So for the rest of this session, I will just call out a couple of these projects and try to share what exactly the problems are that they're trying to solve in this area. So first we'll start with the KubeEdge, which is an IoT edge platform. It tries to tackle the device edge problem and IoT edge problem. So having the central control plane managing the constraint devices with the same Kubernetes API. And in order to solve that problem, they are providing a lot of components and rewriting Kubernetes services like KubeBus, which allows the Kubernetes control plane to work even in this kind of environments, and enabling to schedule the pods on the lightweight agents and controlling them over the unreliable network. Virtual Kublet is on the first look a similar thing, but it focuses only on a single job, and it is to provide a framework for implementing alternative Kublet implementations. So it came from a different origin. It came from the use case of trying to scale out the Kubernetes cluster to the resources, to the other resources in the cloud center. But you can see that virtual Kublet can be used to implement a Kublet API for devices that for any reason can be a proper Kubernetes node. And one of the examples of using virtual Kublet in this context is Azure IoT Edge connector for Kubernetes. So you can take a look a bit more about that there. K3S is also a recent project by Rancher, and it focuses primarily on solving the infrastructure problems. So solving about how to deploy Kubernetes clusters in the edge environment. So it provides like a lightweight Kubernetes distribution, which should be easy to deploy should be used to easily deploy Kubernetes cluster on a small cluster of devices on the edge. Finally, Eclipse IOFog is is another interesting project trying to provide a microservices framework for the edge, trying to implement a lot of helpful tools and concepts so that developers can easily deploy containerized workloads on the edge. They are active in the working group as well, and they are moving their implementation towards the Kubernetes solution. So that's basically where we are at the moment with this working group. So all these topics have been discussed through the regular calls and other resources that the group have, and try to be captured in form of this presentation deck and the white paper, which we try to maintain. And this is just the beginning. So this is kind of trying to be like an introductory material for everybody new coming to this area and trying to tackle these kind of issues in the Kubernetes context. So in the future, what we are talking about now is digging into a certain topics of certain aspects of all this, and trying to provide again best practices and blueprints of how we're gonna solve particular challenges. So two things that popped up is the security and the data plane, the messaging aspect of edge computing that will be discussed in the future. So here are a couple of links, useful links to the working group. So we meet every 2 weeks, and we alternate between 2 time zones in order to have a better cover for both West and East based folks. Next meeting will be next Wednesday, I think, 10 AM Pacific. You can always reach us on the message group and the Slack, and we'll be present at the next KubeCon EU, trying to prepare more material by then, and talk to more people in person. So I hope I got you a bit interested into the topic. So if you have any questions, pop up on the Slack and ask there. There's a lot of folks ready for any kind of discussions. If you have any interesting use case, that's also very valuable. So we would like to hear from you. And that's all I had for today. Thank you.
Jan, thank you so much. Great presentation, and also thanks a ton for putting all the energy into this group. It's really important stuff, and it's wonderful to have people working to try to avoid duplicate efforts and things like that in this space. Things are moving so fast. Just want to let everybody know, call out for questions. If you have any questions, just go ahead and click on the Q&A icon down at the bottom of the Zoom screen and drop them right in there, and we'll go through those as we have time. We just have probably a pretty small amount of time here at the end to pick up any questions that come in. But one thing in the Q&A there, Dan, is that people are interested in materials around this stuff, the slides, things like that. So I know you have like a white paper linked in here. Is this particular deck, and I'm pretty sure it's going to come out with the link for the presentation, but is this deck, or for the webinar, but is this deck available online as well?
Yes, in another form, yes, but I will share with the group and put it So I think the white paper have a lot of have a resources section where there's a lot of other white papers and the materials generally available for the Edge topic, which I think could be interesting for the people interested into that. And basically, yeah, just monitoring the meeting notes and agendas, people can find a lot of presentations that we already had during the work group meetings, and all the materials are shared there. But I'll definitely share this with you guys, and we can yeah.
Fantastic. So it'll come through CNCF channels, but also it'll be in the white paper down in the resources section.
Yeah.
And I imagine it's kind of a living, breathing document, right? I mean, it's going to evolve as, you know, more ideas and more kind of solidity comes to different parts of the equation, right?
Yeah. So we started the white paper basically just as a means to come to the, as I said, common vocabulary and just a way to understand each other. So later on, the work shifted a little bit toward this kind of slide presentation format, but we'll try to put the resources back into the white paper and publish it. And I think it should be an important deliverable to have this kind of concise introduction to the topic somewhere, and have it like with a constrained topic. And then, as I said, all other topics that we are trying to tackle next will be presented at a different kind of white papers or demos or blueprints, you know, whatever group comes up with.
Gotcha. And you know, a lot of folks are sort of chiming in on the vagueness of the overall Edge architecture, and you and I were kind of talking before the webinar a little bit about this. There's, you know, 50 million different solutions out there, and they all kind of have different ways of doing things. Do you see that ever coalescing, or to some degree? What are your thoughts on, you know, kind of archetypal, you know, sort of architectures?
Yeah, I think it's hard to say, because as you can see from this, it really what Edge means to different people is kind of completely different kind of things. So I think in the end there will be a couple of different architectures provided for different kind of use cases. So we can see like a KubeEdge tackling only the IoT use case, but other people are interested in the Edge in the retail. So it will be hard to come up with a single, so to say, platform to solve all the particular problems. But I think having all these kind of tools will help people to actually, you know, solve these use cases depending on their needs.
Yeah, and you guys have started the discussion, which is great, you know, so that all of the lint can come out of the equation and get sifted. There's a question here that ties into that. So specifically for telco folks who obviously care a lot about networking, are you guys looking at tackling some of those challenges and trying to provide guidance around that aspect? So,
you know, the group is open for everybody that has a topic that wants to discuss. Of course, it's on the agenda. We haven't tackled it yet, but you know, it's there.
Gotcha.
So if anybody wants to join and start a conversation around it, that will be awesome.
Right. And what's the best way for people to join? Just show up?
Yeah, just show up. So the group is completely open. There's we try to keep the product marketing at a minimum. So try to keep the discussions as technical as possible. So it's best to join the Slack and to join the meetings and you know, start from there.
Gotcha. And there's maybe time for one more question. Do you see the propagation of lightweight container kinds of technologies for the Edge being important?
Yes, yeah. I think in the certain use cases, we already see that, for example, looking at the IoT gateways, people just want to use containers and the containers workloads. So I think we will see more and more efforts being put into that area as well.
Gotcha. Great. Well, Dejan, thank you very much. And folks, I think we got to most of the questions, maybe missed one of them. So apologize that we didn't have time for all of them, but feel free to, engage through, all the resources that are provided here. And again, thanks everybody for attending. Thank
you for having me. And, for all the questions, the best thing is to ask directly on the working group links, and there will be a lot of folks there willing to discuss all the aspects of this. Perfect. Thanks again for having me.
All right. Bye-bye, everybody.